Hello, I'm AL-DIZER Hassan. We are talking about graph algorithm, topological sort, and Hamiltonian pairs. We are talking first the graph algorithm. Graph algorithm order the number of vertices in the graph, size the number of edges in the graph, vertex degree the number of edges that are incident to a vertex, isolated vertex, a vertex that is not connected to any other vertices graph, self-loop, and edge from vertex to itself. Directed graph, a graph where all the edges have direction indicating what is the start vertex and what is the end vertex. Undirected, a graph with edge that have no direction. Weight graph, edge of the graph has weight. Unweighted graph, edge of the graph has no weight. There are 10 graphs algorithm. First, breadth first search. Breadth first search, traversing or searching is one of the fundamental operations which can be performed on the graph. In breadth first search, we start at a particular vertex, explore all of its neighbors at the present depth before moving on to the vertices in the next level. Unlike trees, graphs can contain cycles, a path where the first and the last vertices are the same. Hence, we have to keep track of the visited vertices when implement BFS. We use a queue data structure. Breadth first search application used to determine the shortest path and minimum spanning trees. Used by search and engine crawler to build index of web page. Used to search on social networks. Used to find available neighbor nodes in peer-to-peer networks such as BitTorrent. Number 2, depth first search. Depth first search or DFS, we start from a particular vertex and explore as far as possible along its branch before retracting backtracking in DFS. Also, we have to keep track of visited vertices when implement DFS. We use a stack data structure to support backtracking. Applications used to path between two vertices, used to detect cycles in a graph. Used in topological sorting, used to solve puzzle having only solution. Number 3, shortest path. The shortest path from one vertex to another vertex is a path in the graph such that the sum of the weight of the edges that should be traveled is minimum. Figure 4 shows an animation where the shortest path is determined from vertex 1 to vertex 6 in a graph. Algorithm. Diggs-Crash shortest path algorithm, Bellman-Ford algorithm. Application used to find direction to travel from one location to another in mapping software like Google Maps or Apple Maps. Used in network to solve the mean delay path problem. Used in abstract machines to determine the choices to reach a certain goal states via transition among different states. Logic can be used to determine the minimum possible number of moves to win a game. Number 4, cycle detection. A cycle is a path in a graph where the first and last vertices are the same. If we start from one vertex, travel along path and end up the starting vertex, then this path is a cycle detection. In the process of detection, this cycle figure 5 show an animation of traversing cycle. Algorithms. Fluid cycle detection algorithms, Brent algorithms. Application. Use distributed message-based algorithm used to process large-scale graph using a distributed processing system on a cluster. Used to detect deadlocks in a current system. Used in cryptographic application to determine case of a message that can map that message to the same encrypted value. Number 5, minimum spanning tree. A minimum spanning tree is a subset of the edges graph that connect all the vertices with minimum sum of edge weight and consists of no cycles. Algorithm. Primes algorithm, Kruskal's algorithm. Applications. Used to construct trees for broadcasting and computer networks. Used in graph-based cluster analysis. Used in image segmentation. Used in regionalization of social geographic areas where regions are grouped into contiguous. Number 6. Strongly connected component. Strongly connected component. A graph is said be strongly connected if every vertex in the graph is reachable from every other vertex. Algorithms. Cross-Arrajus algorithm, Target's strongly connected components algorithm. Applications. Used to complete the Dulmage-Mendelssohn decomposition, which is classification of the edges of a tripartite graph. Used in social network to find a group of people who are strongly connected and make recommendation based on common interests. Number 7. Topological sorting. Topological sorting of a graph is linear ordering of its vertices so that for each directed edge or UV in the ordering vertex you came before V. Figures and show example of topological ordering vertex. 1. Algorithm. Scans algorithm. The algorithm based on depth first search. Application. Use instruction scheduling. Use in data serialization. Used to determine the order of computation tasks to perform in makefiles. Used to resolve symbols dependencies in linkers. Number 8. Graph coloring. Graph coloring assign colors to element of graph while ensuring certain condition. Vertex coloring is the most commonly used graph coloring technique. In vertex coloring, we try to color the vertices of a graph using K colors, and any two adjacent vertices should not have the same colors. Other coloring techniques include edge coloring, face coloring. Algorithms. Algorithm using breadth first searching or depth first search. Greedy coloring. Application. Used to schedule timetable. Used to assign mobile radio frequencies. Used to model and solve games such as Sudoku. Used to check if a graph is a tripartite. Used to coloring geographical maps of countries or states where adjacent countries or states have different colors. Number 9. Maximum flow. We can model a graph as a flow network with edge width as a flow capacity. In the maximum flow problem, we have to find a flow path that can obtain the maximum possible flow rate. Algorithms. Ford-Fulkerson algorithm. Edmonds-Karp algorithm. Dynix algorithm. Application. Used in airline scheduling to schedule flight crews. Used in image segmentation to find the background and the foreground in image. Used to eliminate baseball teams that cannot win enough games to catch up to the current leader in their division. Number 10. Matching. A matching in a graph is set of an edge that does not have common vertices. And 2. A matching is called maximum matching if it contains the largest possible number of edges matching as many vertices possible. Algorithm. Hofcroft-Karp algorithm. Hungarian algorithm. Blossom algorithm. Application. Use making to match brides and groom. Stable marriage problem. Use determine vertex cover. Used to transport theory to solve problem in resources allocation and optimizing in travel. Next, we're talking about topological sort. Topological sort. Sorting vertices of a directed acrylic graph in an ordering of the vertex V2, V1, V2, being in such a way that if they are in edge directed toward vertex from vertex Vi and then V1, Vi comes before Vj. For example, consider the graph given. Topological sorting of this graph is 1, 2, 3, 4, 5. There are multiple topological sorting possible for a graph for the graph given above on another topological sorting is 1, 2, 3, 4, 5. In order to have topological sorting, the graph must be not contain any cycles. In order to prove it, let's assume there is a cycle made of the vertices V1, V2, V3, Vn. That means there is a directed edge between Vi plus 1 and between Vn and V1. So now if we do topological sorting, then Vn must come before V1 because of the directed edge from Vn to Vn. Clearly V1 plus 1 will come after Vi because of the directed from Vi to Vi plus 1. That means V1 must come before Vn. Well, clearly we've reached a contradiction here. So topological sorting can be achieved for undirected and acyclic graph. Let's see how we can find a topological sorting graph. So basically we want to find a permetum of the vertices which for every vertex all the vertex Vj having edge coming out and directed toward comes before V and well. Here's the sample of topological sort. Hamiltonians. Hamiltonian cycle is a closed slope of a graph where every mode vertex is visited exactly once. A loop is just edge that join a node to itself. So Hamiltonian cycle is a path traveling from a point back to itself, visiting every node en route. If the graph width is more than node, i.e. a non-singleton graph has this type of cycle. We call it Hamiltonian graph. There isn't any equation or general trick to finding out whether a graph has a Hamiltonian cycle. The only way to determine this is to do a complete and exhaustive search going through all the options. That's all, and thank you.